question is an implicit differentiation. Okay, this is an implicit function. So finding the derivatives of an implicit function is implicit differentiation. So how do we solve it? It's very simple. First, we say solution. Okay, now we are differentiating each term separately, and that is all. So what do we do? If you are writing any theory-based exam question, you have to follow this process. First, you say d x squared with respect to x. So we are differentiating x with respect to x plus d y squared with respect to x plus keep 2x constant, differentiate y with respect to x plus keep y constant, differentiate 2x, differentiate 2x, okay, with respect to x, then equal to d5 with respect to x. So this is what you do for each term. Now, anyone you're differentiating, be very careful. Here, if you differentiate x squared, you have 2x. Okay? Because we actually differentiated x with respect to x, we have dx ds plus. If you differentiate y squared, you have 2y. Also, we differentiated dy, y here. So you have dy with respect to what? X. We are differentiating y here, keeping 2x constant. If you differentiate y, you have 1 dy dx. Okay? Plus, we are keeping y constant here. You differentiate 2x, you have 2 dx dx. And this is a constant. If you differentiate a constant, you have 0. So this can cancel out this because the SDS will go. This cannot to stay. This cannot to stay. But this can cancel out this. It will go. So what do we have? 2x plus 2y dy dx plus 2x dy dx plus 2y equal to 0. Collect like terms. Shift 2x and 2y that doesn't have dy dx to the right hand side. So dy dx is common here. So I'll say dy dx into brackets. So 2x dy dx, if you cancel it here, this will go. You will be left with 2y plus 2x dy dx divided by dy dx. Dy dx will go. You'll be left with 2x. Okay? So that this one's going crossing over the equality sign, their sign will change. This will change to minus 2y and this will be minus 2x. So we divide both sides by the coefficient of dy dx. Alright, so that we'll be able to have dy x is equal to, this is common, minus 2 minus 2 is common, we bring it back, minus 2 into y plus x, okay, plus minus 2y divided by minus 2, we get y, put it here, minus 2x divided by minus 2, we get s, put it here, and s plus s. So the same thing happens here, we factorize 2 out, we get y plus x. You notice that what is here is here, you cancel out, what is here is here, you cancel out, so that dy dx is equal to minus 1. So you see dy dx is equal to minus 1 as required. So that is how you solve this question if you are writing a theory-based question. However, we can solve this question without passing through this process for objective-based question. So if you're writing an objective-based question, you don't need to take this long process. All you just need to do is use shortcuts to solve it. Alright, so I'm going to show you how we can use shortcuts to solve the same question. Alright, shortcut. Shortcut method. So what should you do? When you see a question like this, your answer be this. Dy dx is equal to, you draw two lines to separate numerator from denominator. Just draw a line to separate numerator from denominator. Now, a function y equal to function of x, you notice that y is at the left hand side, x is always at the right hand side. So anywhere you see x squared, x alone should be at the right hand side. But you are seeing this at the left hand side, so it's an error. And because s is this side, y is this side, y is meant to be here, s is meant to be here. So y is meant to be here, s is meant to be here. S is not meant to be here, but y is meant to be here. You see these two s that you are differentiating and keeping this one constant, y. As you kept y constant, you are differentiating s. As long as you are differentiating s is not meant to be here. S is meant to be here, but it's not there, it's here. And when that occurs, like s squared now, you differentiate it, it's not meant to be here, but if you differentiate it, the sign will change because it's not meant to be there. So let's go. Differentiate s squared. You have 2x. Is s supposed to be here? No. So you have minus 2s. And anytime you differentiate s, you place it at the numerator. Differentiating y, is y meant to be here? Yes, see it here. So differentiating y squared, you have 2y. And anytime you differentiate y, you place it at the denominator. So you now say 2y. I'm done with these two. I come to this place and say differentiating 2x. That means I'm keeping this constant. If I keep y constant, I differentiate 2x. Is x meant to be here? No. So when I differentiate 2x, I get 2. 2 times y, 2y. Now, this is plus, and the result will be minus 2y. Because I differentiated, the differentiation was on 2x. I differentiated 2x. Now, when I keep 2x constant, I'm differentiating y. I'll get 1. 1 times 2x is 2x. So I actually differentiated y. And y is meant to be here. So I'll write it at the denominator. Remember, I wrote that of x at the numerator. So now, plus 2x. I know you ask question, how come y is up and s is down? I said, if you keep 2s constant, you differentiate y. What are you differentiating? Y. And if you differentiate y, here is y raised to power 1. So the answer must be 1. 1 times 2x will give you 2x. And what have you differentiated? Y. So it should go to the denominator. Forget about it. You are seeing 2x. If you keep y constant, you are seeing y now. You did not differentiate it. So it's there. You are differentiating 2x. That means it's not supposed to be here. So it will be minus. So if you differentiate 2x is 2. That is why you are seeing 2 and multiply it by the constant y that you kept constant. So you have minus 2y. Where will you place any value you differentiate for x and the numerator? Differentiate 5 is 0. This is meant to be my answer, but I need to simplify to the lowest term. So how do I simplify? Very simple. Minus 2 is common. Write minus 2 into x plus y over 2 into x plus y. So this is same, this is same. So that our dy, the x is equal to minus 1. If you got the same question in that first question, say it in the comment section. If you actually learned this shortcut, you can try it and let me know in the comment section that you've solved it and you've understood it, so that I will know how best I can explain in my next section. For now, like, share, and subscribe to my YouTube channel. Have a wonderful day. Bye.